when we go to example 3, it says the position of a particle is given by the equation S is equal to f of t, which is equal to t cubed minus 6t squared plus 9t, where S is the displacement in meters and t is the time in seconds. Determine the velocity when t is equal to a. Well, we're doing essentially the exact same thing we did in the last example. If we're doing the velocity when t is equal to a, then we're going to be saying that f prime at a is going to equal the limit as h approaches 0 of f of h plus a minus f of a divided by h. Now, when we sub it into this formula, then I have the limit as h approaches 0, and in this case, I'm going to have h plus a cubed minus 6 h plus a squared plus 9 h plus a. I'm going to subtract from that a cubed minus 6a squared plus 9a. And it's all over h. I'm going to expand this all out, being careful with the h plus a cubed, which is going to give me h cubed plus 3h squared a plus 3ha squared plus a cubed. Then I have negative 6h squared minus 12ah minus 6a squared plus 9h plus 9a minus a cubed plus 6a squared and minus 9a. And it's all over h. From here, I can see that I can cancel out the positive a cubed and the negative a cubed. I can take away the negative 6a squared and the positive 6a squared. I can take away the positive 9a and the negative 9a. And all I'm left with is the limit as h approaches 0 of h cubed plus 3h squared a plus 3ha squared minus 6h squared minus 12ah plus 9h all over h. And even though we have way more terms than we have in our previous examples, we still have a common factor throughout all of these of h. Limit as h approaches 0 of h bracket h squared plus 3ha plus 3a squared minus 6h minus 12a plus 9 all over h. And when I cancel this out, all I'm left with is 0 squared plus 3 times 0 times a plus 3a squared minus 6 times 0 minus 12 times a plus 9. And lo and behold, anything times 0 gets canceled out. And I wind up with f prime at a is 3a squared minus 12a plus 9. There's our formula. When it says calculate the velocity after 2 seconds, it's just saying replace x with 2. So when I calculate this velocity, I'm just saying that f prime at 2 is going to equal 3 times 2 squared minus 12 times 2 plus 9, or that -3 is our answer, and that is in meters per second. Don't forget to check back here. Is the velocity at 2 seconds. All right, let's take a look at example 4. For example 4, if it says if f of x is equal to the square root of x plus 2, determine f prime and state the domains of f and f prime. So in this case, we're solving for f prime at x. And that's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Or the limit as h approaches 0 for the square root of x plus h plus 2 minus the square root of x plus 2 over h. Now, in order to solve this, we need to rationalize that numerator. So we're going to multiply the numerator and the denominator by the conjugate. Square root of x plus h plus 2 plus the square root of x plus 2. This is going to give me the limit as h approaches 0 of x plus h plus 2 minus x plus 2. And that's all going to be over h, and the square root of x plus h plus 2 plus the square root of x plus 2. That's going to leave me with the limit as h approaches 0 of x minus x is going to cancel out, 2 minus 2 is going to cancel out, and I just have a denominator of numerator of h. Denominator is still h, and the square root of x plus h plus 2 plus the square root of x plus 2, and those h's are going to cancel out to leave me with just a 1 in the numerator, which means I have 1 over the square root of x plus 0 plus 2 plus the square root of x plus 2, which is the same as just x plus 2 and x plus 2, or 1 over 2 and the square root of x plus 2. Now, what does this mean? This means that if f of x is equal to the square root of x plus 2, then the domain is going to be x is an element of -2 to positive infinity, where it can equal -2. If I say that f prime of x is equal to 1 over 2 and the square root of x plus 2, then that means that the domain in this case is very similar. The only difference is because it's in the denominator, I can't actually equal -2. But we will notice that the domain of f prime is always going to be a subset of the domain of f. So the domain of f prime has to exist within what that original domain of f is, even though it can take away some of the values.